In this video, I'll go through some examples using logarithmic functions in bases other than 10 and e. So in a previous video, we talked about the logarithm function for a base b and derived that from this exponential function y equals b to the power x, which is equivalent to the log b of y is equal to x. B is the base, and we talked about base 10, which is the common log, and base e, which is the natural log. But what about other bases? So these three examples are going to show us how to work with other bases. So first of all, just to kind of set up some intuition, let's think about solving this equation. So x is 2 to the power y, which is equal to 16, and we want to find the value of y. So if I take the base 2 logarithm of both sides, I will have log 2 of 2 to the y equals log 2 of 16. And remember, the logarithm and the exponential function are inverse functions, so the left-hand side simplifies to y, and the right-hand side is, well, we're going to have to figure out what that is. Let's think about the powers of 2. So 2 to the 1, 2 squared, 2 cubed, 2 to the 4, 2 to the 5, etc. So 2, 4, 8, 16, 32, etc. So here we have 2 to the 4 is 16, and so that's what we're looking for. We're looking for the power of 2 that would give us 16. And so the answer here is that y is equal to 4, because 2 to the power 4 is equal to 16. So for this example, we were able to figure out what the answer was, because it turned out that 16 was an integer power of 2. But if we look at the next example, that's not the case. There is no integer for y such that 2 to the power y is equal to 20, because we can see that here. We go 2, 4, 8, 16, and then we go to 32. So we know our answer is somewhere between 4 and 5. But how do we derive that answer? So it turns out that we're going to use one of the logarithms that we can calculate, in particular either common logarithm or natural logarithm. Because if we were to proceed as we might normally, we would start by going, okay, log 2 of 2 to the y equals log 2 of 20, and then we would get y equals log 2 of 20, but we don't have a way of calculating this, because most calculators and computers will only allow us to calculate common logs and natural logs. So we need to come up with something else. So what if we tried using one of the logs that we do know how to calculate? Let's say the common log, so base 10. So let's take the base 10 logarithm of both sides and see what happens. So we'll do log 10 of the left-hand side and the right-hand side. And now, if we look at this left-hand side here, we can use one of the properties of logarithms, which we went through in another video. We know that the log of 2 to the power y is the same as y times the base 10 logarithm of 2. And then the right hand side, we'll just leave that alone. And so now we've got an equation that we can solve for y. Y is going to be equal to the common log of 20 divided by the common log of 2. And if we do that on the calculator, we get the answer 4.3219. And then we can check that answer by going back to our original equation, 2 to the power 4.3219, and that does indeed come to 20 to 2 decimal places. Let's do one final example, number 3 here, and let's use the natural log for this example. It doesn't actually matter whether we use the common log or the natural log, just as long as we're consistent. So let's use the natural log. So here we're going to have the natural log of 5 to the power y equals the natural log of 20. We'll use the property of logarithms on the left hand side to write this as y times the natural log of 5 equals the natural log of 20, and then we'll solve that equation for y. So we'll have log of 20 divided by log of 5, and we can do that on the calculator. That comes to 1.8614, and then we can check we've got the right answer by going back to our original equation and calculate 5 to the power of 1.8614, and that indeed comes to 20 to 2 decimal places. So that's a few examples of working with logarithms where we have to work a little bit harder in order to formulate the equations so that we can use base 10 or base e to solve the problems.